All right, so today we're going to continue our game of Gauss-Jordan elimination, but we're going to extend it to systems where you have three variables and three equations. So you have three equations, three unknowns. Now, this is considered a system of linear equations, but when you have three dimensions, the line is now a plane if you wanted to visualize it. But really, the process is the same. The process of Gauss-Jordan elimination is the same. Now, the goal is slightly different, okay? So we want to solve for x. We want to find values of x and y and z that satisfies all three of these equations. So what we want to do, our end goal, is to create a matrix that gives us x and y and z. So we want something that looks like x 1x plus 0y plus 0z equals some number. We want 0x and 1y plus 1y plus 0z to, again, just give us some number. I'm just going to use asterisks just to say, okay, that's just some arbitrary number. And then we want, also, we want to solve for z. So we want an equation that is 0x plus 0y plus 1z is some number. Okay, so this is our new goal, right? This is our goal, but it's in three-dimensional form. So because we have three variables, we have to solve for all three variables. Okay, but the process is the same. We have the same three row operations. I've written them up here for reference. We can interchange two rows. We can replace a row with a constant multiple of the same row, and we can replace a row with that row plus a constant multiple of another row. All right, so same three legal row operations, and now we just have a little bit different goal. All right, so we're going to start by writing the augmented matrix for this system of equations. So we're just going to take the coefficients from each of the variables. 2, 4, 6, and 22. We have 3, 8, 5, and 27. And the last one, so it's negative x, which is negative 1 times x, plus y, which is just 1y, and 2z, so 2. And 2 is the number on the right-hand side. All right, so there's my augmented matrix for the original system of equations. And the next thing we need to do is figure out a way. I'm going to, again, work column by column, and I want this first column to look like the goal, 1, 0, 0, right? So what can I do to get a 1 in the upper left-hand corner? Well, first thing I notice is that, I can divide all of these numbers by 2, right? These are all even numbers. So I'm just going to start by taking 1/2 of row 1, okay? I'm just going to replace that row with 1/2 of each number is just going to be 1/2 of what it is now. So 1/2 of 2 is 1, and 1/2 of 4 is 2. We have 3, and then 11. Okay, just taking 1/2 of each value. And that's it. I'm just gonna copy the other rows down as they are. So 3, 8, 5, negative 1, 1, 2. All right, 27 and 2. All right, so now I have a 1 where I want it, and now I want to get zeros below it. Okay, so what's my next row operation going to be? Well, I can see easily that I can just add row 1 to row 3, and then this number would become 0 because 1 plus negative 1 is 0. So I'm going to take row 3 and I'm going to add row 1 to it. That's an easy one. Now I can actually do 2 steps in one. I'm also going to take care of this row as well, row 2, because if I take row 2, and I replace it with row 2 minus 3 row 1, then I'll get a 0 where I want it. And I can do both of those steps at once. All right. I'm going to try doing both of those steps at once. All right. So I'm going to make a little note to myself as far as what is negative 3 times row 1. So that's going to be -3. So negative 3 times 1 is -3. This is going to be -6. This is going to be -9. And this is going to be -33. Just making a little note to myself. So that when I, when I replace row 2, I am adding the right multiple of row 1. All right, so I'm not going to change row 1. So that's just going to stay 1, 2, 3, and 11. Okay. And now I'm just going to take row 2 and add -3 times row 1. So 3 plus -3 becomes 0. 8 minus 6 is 2. 5 minus 9 is a -4. Right? Let's see. Let me make sure. -4. And then 27 minus 33, I believe, is a -6. I have to keep checking myself, checking my answers, make sure I'm doing this right. All right. So now I've done this row 2 minus 3 row 1. And now I'm going to ignore those little notes because now I just want to take row 1 as it was, the original row 1, and add it to row 3. So that'll give me 0. 2 plus 1 gives me 3. 3 plus 2 is 5. 11 plus 2 is 13. All right. All right, so I've got column 1 done. Column 1 is the way I want it. So I'm going to move on now to column 2, and I'm going to try to get 0, 1, 0. All right. That's my goal, to make that into 0, 1, 0. Well, let's see. What should I do? Now, first thing I can see, I can just take half of everything in the second row is even. So I'm just going to take 1/2 of row 2. Okay. That gives me the 1 where I want it also. So that's nice. So I'm just going to take that little baby step, and I'm not going to change row 1 at all. So I'm just going to copy it down, and I'm going to take 1/2 of the second row. So 1, -2, -3. Okay. And I'm going to leave row 3 as it is. So 0, 3, 5, and 13. Okay. All right, so I got the 1 where I want it, and now I want zeros above and below it. So I think what I'm going to do, let's just do, if I take row, I'm going to work on this 3 here. So I'm going to take -3 times row 2 and subtract it or add it to row 3. All right, so row 3, we're going to replace that with row 3 minus 3 row 2. All right, let's take that step first. So what do I get when I do that? So I'm not going to change row 1 at all, so I'm just going to copy it down. 11, right? I'm not going to change row 2 at all either. So 0, 1, -2, -3. And now I'm going to make a little note to myself. So if I take -3 times 1, that becomes -3. -3 times -2 becomes a +6. -3 times -3 becomes a +9. So those are the numbers that I'm going to add to the third row. All right, so then I get 0, and then 5 plus 6 is 11, and then I have 13 plus 9 is 22. Okay, there's my new augmented matrix. All right, so now I need a 0 above as well, and I also see that I can divide, both of these numbers here are divisible by 11. So I'm going to do a couple of steps in one again. So I'm going to take 1/11 of row 3, and I'm going to take row 1, and I'm going to replace it with row 1 minus 2 row 2. So basically I'm using this 1 to zero out the row above it. Okay, so I'm going to make a little note to myself. What is -2 times row 2? It's going to be -2. This becomes a +4, and then this becomes a +6. Okay, so that's what I want to add to row 1. All right, so of course I'm kind of ignoring this 0 because I know 0 times -2 is just going to be 0. All right, so 0 plus 1 is just 1. Negative 2 plus 2 gives me 0. 3 plus 4 is 7. And then 11 plus 6 is 17. Okay. Now I'm going to leave row 2 as it is. 0, 1, negative 2, negative 3. And then I said I was going to take 1/11th of row 3. 0, 0, 1, and 2. All right, I'm getting closer. I've got the second row, or second column done. I got the first 2 columns look like my goal. All right, so now I just need to work on the third column, and I've actually got a 1 now in the lower right-hand corner here where I want it. So I'm gonna do 2 steps in 1 again. If I take, I want to zero out these 2 numbers above the 1, right, in the third column. So what I'm going to do, I'm going to take row 1, and I'm going to subtract 7 times row 3, right? So I can make little notes to myself here and say, well, 0 times negative 7 is 0, 0 times negative 7 is 0. This becomes a -7, this becomes a -14. Okay. Now I can also, at the same time, I can also zero out the row, the second row, right? So I can take row 2, and if I add 2 times row 3, I'll get a 0 where I want it. So let's first of all just start with row 1. Okay. So I'm just using the third row to zero out this 7, right? So I'm adding -7 times row 3. So this becomes 1, 0, 0, right? Because 7 plus -7 is 0. And then 17 minus 14 gives us 3. Okay. Let me just finish out this matrix. All right. So now I'm going to make new notes to myself here. I'm going to erase those. And then I want to add 2 times row 3 to row 2. All right, so 2 times row 3 becomes 2 and 4. All right, so then I'm going to get, for the second row, I'm going to get 0, 1, and then adding 2 to -2 gives me the 0, which is what I want. And then -3 plus 4 gives me a 1. And then I already have the last row the way I want it. So 0, 0, 1, and 2. And there we go. I won the game. I've met the goal. And now I know the values for x, y, and z. Because if I just take that augmented matrix and turn it back into equations, this augmented matrix is equivalent to the system of equations that tells me that 1x plus 0y plus 0z is equal to 3. 0x plus 1y plus z is equal to 1. And then 0x plus 0y plus 1z is equal to 2. Right? So I can put my solution down here. My solution is 3, 1, 2. Okay? Now, it's always a good idea to check. Okay? So I'm going to take those values. Actually, can I get it? I have to go back to the original equation and put those x and y and z values into each one of those equations and make sure that this point, this x, y, z values, these x, y, and z values meet, or satisfy those equations. All right, so now you can't see, you could probably see it if you have this written down on your paper, but we have 2x, x is 3, plus 4y, y is 1, plus 6z, which is 2. And we want that to equal 22. That's the first equation. And so we get 6 plus 4, that's 10, plus 12, that's 22. Okay, that checks out. All right, so the next equation is 3x, 3 times, my x value is 3, plus 8 times y, plus 5 times 2, times the z value. And that should equal 27. So we have 9 plus 8, so that's 17. 17 plus 10 is 27. Perfect. That works. All right. Last equation is negative x, so negative 3 plus y, which is 1, and then plus 2z, which is 2, should be equal to 2. All right, so I have negative 3 plus 1, that's negative 2, and negative 2 plus 4 is a positive 2. Okay, that works. All right, so we can verify now that we have the right solution to this system of equations. All right. So the only thing different in this set, I split it up because this is a lot. It's a difficult topic, and so I've just split it up into last time we were doing systems of 2 equations and 2 unknowns, and now we're doing systems of equations and 3 systems of equations with 3 unknowns and 3 equations and 3 unknowns. Okay, so the next example is a lot like this one. So you should give it a try. You should give it a try, and then you can come back to the video and watch the video if you have trouble with it. All right. So I'll meet you in the next video.